Hi, my name is Cupano, and welcome to this video on building sovereign AI for amateur radio and signals intelligence, or SIGINT. What started as a sovereign AI project back in the spring with amateur radio as a use case has evolved into a sovereign signals intelligence platform with trials and tribulations shared along the way. My hope is this talk and the online materials we'll be sharing will help get you off to a good start in your own journey with signals intelligence and AI. Who am I? I started with shortwave listening and then got into the CB craze. And then in the early 80s, when I moved from New Jersey to New York State, I founded a local amateur radio club that did novice license testing. And it went on from there. I've supported two ARRL books over the years. Anything else on me, go to my website, find me on LinkedIn, or my occasional babble on some of the Facebook amateur radio groups. Finally, I do not like spectrum shaming. Any way you got into this amateur radio is a good vector, whether it's CB, GRMS, playing with Meshtastic, all these other wireless stuff out there. It's all good. Above all, be you. This is the agenda I'll be journeying through. I understand we all learn differently, some visually, some just reading, and some from an interactive presentation. To help you along, here is a QR code so you can download the presentation right now to make it easier to follow along with, even though this is a guided slide on the video. Hey, like I said, everyone learns a little bit differently. Sovereign AI is about keeping it all in-house: the compute, data, sources, network connections, storage. Open source LLMs are preferred for transparency and auditability. Being sovereign limits opportunities for data leakage, namely intellectual property, but also telemetry sent by software packages. With all data local, we have nothing in the way, such as embargoes and changing sanctions that are out there. Even if you are into amateur radio or not into amateur radio serving as a massive open source laboratory is core to its existence. In my opinion, it's only successful through diversity of participation and thinking. Signals intelligence, often referred to as just as SIGINT, is the broader topic and really what this project is striving towards. Amateur radio just happens to be an easily referenceable use case to start with, given known signals, modes, and where to find them. So here's the concept to start off with the project. What if I could build something that can actually listen across the entire RF spectrum? Remember what I heard, tell you what's actually going on without going to the internet to get further details and pretty much leaking your queries out there. The baseline for this is sovereign solutions. Some organizations out there might be enclaves, but I'm building an enclave. This is the baseline. There's no egress. We turn off all auto updates and any telemetry share from the operating system and installed packages. There's no external compute. All processing is under local and physical control. And no ambiguous data. We start with raw data, raw truth from the SDRs themselves, and into structured formats that we can consume. All data has a chain of custody in its provenance. While a baseline is sovereign, the reality is you will need to consume external assets at some point. What's important is recognizing the point where chain of custody of all the materials and data you have starts trading off with level of trust. And that's when you start getting to the space of trust but verify. Trust but verify challenges the ability to perform the verify. How many of you have verified all the source code in Ubuntu? You haven't, but you trust someone else is, and it's there if you ever decide to go down the deep end path of it. What's important here is that any exceptions are a conscious decision made by, vetted by, and executed by a human. This is just a short list of possible queries using an AI via a chatbot on the front end of such a SIGINT solution. What we've seen, what's the signal I captured? And for that latter, let's take that signal image from a waterfall and capture it with another tool and compare it with a local database of known signal types. And then the third question is using data capture of known signal hardware types, MAC addresses. Occupancy is not a new concept. Signals intelligence, SIGINT, workflow starts with what signals do we see, what frequency they are on, and how strong each signal is. Practice in Bletchley Park as far as trying to develop what a battle order is. I see it, I hear it. Is it warrant further analysis so we can decide the focus of priority of things? The International Telecommunication Union, ITU, is the United Nations Specialized Agency for Digital Technology that produced a methodology back in 2017. From there, we target signals of interest for identification, demodulation, and further analysis. After all, you need to be able to see it before you have anything to do. This is where we start going into the deep dive in the architecture itself. From a 36,000-foot view, 5 tiers with a bridge tier, tier 3.5, where structured payloads from the SDR domain are built for consumption by the AI domain. For those experienced with SDR devices, much of the first 3 tiers will be familiar to you. This view calls out the technology each layer, providing further context and grounding points for those familiar with the AI tools we will be using. The magic from SDR to AI domain occurs in the bridge tier. It's Python scripts, system services, and databases. We'll dig into that for sure. Before I talk about antennas, let me tell you about the compute platform for the hardware was used for a lot of the testing. It was a Dell Precision T5820 with 64 gig of RAM and Xeon CPU. The Xeon CPU is important because it provides you 64 PCI lanes versus an i7 or i9 it has 20 PCI lanes. Think it is the highway to the bus for the cards you're going to use, especially for the GPU in the system. I was lucky the 5820 I had already had like a 150 watt supply in it, so I didn't need to upgrade the power supply. At first, for GPUs, I tried working with an NVIDIA Tesla P40 because 24 gig of VRAM and only maybe about $250. Figured that was going to be a bargain. But physical dimension, it takes up about 3 slots. Once you add on a blower to it to cool it, because it's normally they're put into the rack servers and dependent on passive cooling. Once I got into that, plus this older Pascal architecture, it's very good for specific LLMs. I ended up having to go ahead and spend the $600 for an NVIDIA RTX 5060 Ti, which is built on Blackwell architecture. It only has 16 gigabytes of VRAM, but as we'll talk about a little bit later, it's not going to be important in our conversation. But getting into the antennas, for general signals intelligence, since we're just receiving, wire antennas are our first choice for HF. End-fed wires with a 9-to-1 balun that matches the wire to coax or into the radio. They're readily found on Amazon, and a lot of them are sold with the balloons. Vertical antennas, VHF, UHF, and up. You can use a mobile mag mount antenna on a gutter. That could serve well. The gutter is actually providing the ground or the counterpoise at that point. Some people can go ahead and replace the whip if it's like an old CB or whatever and buy one of those trucker huge whip antennas. Again, you're using it for receive. But the thing I want you to understand is antennas. Bigger is better, wider is better for bandwidth, especially on the lower some of the HF frequencies. But if you have a good antenna, it's going to save you a lot of prying and tweaking and tuning of your SDRs going further down. Yagis, pretty much you already know the signals of interest, typically satellites or VHF you'd be using a Yagi antenna for. Again, if you're using this for more of a fixed location situational awareness, your verticals and wire antennas are pretty much where you're going to be going for. Well, the RTL, SDR, and HACR are for good SDRs to start with. If HF is special interest to you, the RX 888 is considered more advanced. It's got high resolution, allowing you to see the entire HF spectrum at once. It's actually 64 megahertz worth of spectrum, so you're going beyond from 0 to 30 megahertz. The RX 888 can be channelized, serving up many simultaneous signals from a single wideband capture by a dedicated daemon that we'll talk about later. The channels can be demodulated signals using helpful apps like Direwolf for Packer or Multimon NG for other things. If you're just doing HF, the RX 888 is all you need. The HackRF and RTL-SDR are much narrower in their bandwidth, 20 MHz and 2.4 MHz bandwidth respectively, but they have better performance at VHF and UHF frequencies. We use the native tools available to each for the HackRF and RTL-SDR. Since this is a server, we use Ubuntu 24.04 LTS server. Don't install it on desktop. You're going to have a whole bunch of superfluous stuff you need. You're dedicating this as a sovereign AI server and signals intelligence and the security with it. You do use containers, but we go with Podman because we have containers we want to run as rootless, OpenWeb being one of them. System services, we do run system services, but we have them running underneath a non-root ID for them. For drivers, we'll use the SOAP SDRs, some of the drivers for the SDRs like HackRF and RTL SDR. The CUDA drivers, this is for the GPU. As of this posting, 595 was the latest that supports Blackwell. Again, be very conscientious of the version of drivers using because they're still constantly updating. And finally, the fast Fourier transform application that helps you create a wisdom file that helps make the magic of making the calculations much quicker for the SDRs to actually function. The core component between the SDRs and further up the stack is the Radio D daemon by KA9Q. It reads an AD stream directly from SDR and executes a configured set of digital down converters and simple demodulators for various modes, including AM, sideband, CW, and raw IQ mode for use by other programs. And this build is only used with the RX 888. The HackRF and RTL SDR use their native tools. With the RX 888, we can demodulate 18 HF channels continuously off the RX 888, with Radio D piping a channel through Multimon or Direwolf, as I mentioned earlier. For Wi-Fi, Bluetooth, and other similar devices, we actually use the Kismet platform for that. In fact, you'll find in this project that we use Kismet, everything that comes with it, and we'll actually include its use of its user interface. So the only touch point between Kismet and the stack is via the AI domain. So Kismet is the entire SDR domain, has its own UI, but also it feeds into the AI domain, and we'll discuss that a little further. The magic I mentioned about for section 3.5 starts off with, here's these services that run as systemd. They're Python scripts at the end of the day. They're going ahead and doing the capturing for VHF, UHF, and Radio D, which are, again, running a system services non-root, and they're populating a SQLite database called occupancy.db. For Kismet, we keep with its native tools for occupancy and query the latest .kismet file. No producer scripts necessary. I mentioned about the occupancy database that's getting populated. And what queries that database from the OpenWeb UI, there is Python tools we install from within the OpenWeb UI. These are called by the chat queries, and then by chats to query the occupancy database. And also from the chats, you see the one for Kismet. Again, that's a tool we actually recognize from chat that we need to query Kismet. We do have support of RAG. An automated ingest pipeline has been created for RAG that processes files every 4 hours as a system service. You dump it into a folder, it sees it, it'll process it every 4 hours. While it's been built and tested as of this video, it has a system service. It hasn't been really fully populated with RAG, just because we don't want to accidentally include copyrighted materials from our own testing. OpenWeb UI runs sovereign SIGINT reference. What that does is it mirrors the SIGID wiki site and gives you a local copy. It's referenced by the AI. I mentioned about the producer scripts. These are the scripts that get called in from within OpenWeb UI. You'll see in turn how some of them, they pull up CLI tools to do further processing. Why native tools, not MCP? Quite frankly, everything we need is local on the box. MCP for this build for Sovereign is simply going to be overhead. So, and actually keeps the profile very secure. Since you're dealing with Radio D, it's actually doing multicast. Multicast is kept within the box, so we're not actually routing it out to anything else. And again, it's just very tight right now. I do recognize as we expand this to make it more tiered architecture, MCP will have to be revisited. But again, right now it wasn't necessary, and if we create it, it was just going to be add overhead as additional container, additional hops, everything else. Ollama is an open source software platform for running and managing LLMs on your local computer. We use 3 LLMs to support the different task categories we want to perform: reasoning, visioning, and embedding. A single model good at all 3 would not fit in 16 GB of VRAM. Ollama loads 1 model at a time. 3 right-sized models that swap in and out beats 1 oversized generalist sitting in VRAM, regardless of whether the current task needs it. Embeddings specifically benefit from a model trained and evaluated for that exact task, and they actually could be quite small. They're megabytes versus gigabytes. The lesson learned with models is choose models by the job, not by leaderboard ranking. These 3 models form the foundation of new models we create in Web UI. We did go down the path of a 4th smaller model that was an alternative reasoning model to be equipped with. But the trade-off is you have to give a lot more guidance and system prompts for it to be explicit. It'll give you like short, curt answers, but not give you anything more detailed. Again, new models are created, built on the models mentioned. So SIGINT Qwen is built with the Qwen model, plus we add the tools to it that we've mentioned that we populate within within OpenWeb UI. So in OpenWeb UI, we'd create these models, have them use Qwen, and we would actually tell them the tools they're going to be used with. For each of the new models, we add the following system prompt. The highlighted are functions in the tools we add in OpenWeb UI. There are actually functions within those name scripts I previously called out. Those tools I mentioned in Web UI, here they are. Call this a Python function. And like I said, those previous functions in the prompt are called from within those functions. They're assigned to the new models, and there's those core models that go with them. Because OpenWeb UI remains frequently updated, we stick with OpenWeb UI 0.10.2 for this build. As stated, we keep with Kismet's native tools in our build. Kismet UI does deeper analysis on Wi-Fi, Bluetooth, and other known wireless technologies. It is important to note that Kismet is completely standalone in the SDR domain, as I mentioned before. In the AI domain, the latest .kismet file is what is referenced, and not occupancy database. Kismet is what has inspired the occupancy database structure. OpenRX is used for deeper signal analysis, but to use SDRs with this, you need to toggle their use with a CLI script we have that toggles the SDRs between AI and interactive use. So AI is its normal every day where it's populating the AI occupancy. You flip the switch, then it's made available for interactive use. But when they're in interactive use, the SDRs no longer populate occupancy DB. I'm not a fan of other presentations that go through all this and they'll give you, hey, a taste of show me. Well, here it is, show me. What you're looking at is the OpenWeb UI interface. Actually in the chat, in beginning the chat, I've selected SIGINT Qwen as the model I'm going to work with that has all the functions I told you that are attached to it. I gave it a just simple question, how many signals have you seen on an HF? And I even misspelled many. What I'll do is I'll go through and I'll even say export it to close up that function I mentioned that is within the functions of the tool. And here it gives me an answer of what it's seen. Same thing for Wi-Fi. Here it pulls up Kismet summary. Again, I'm just querying the latest .kismet file. Nothing more. So again, everything from the summary below is pure Kismet. All we did is write a script that actually queries it from OpenWebUI. And here we have a bit of taste of some of the detections. Caveat emptor. Some things you need to be aware of in this build. You heard me repeat this a couple times, but I repeat things because they often say if we say something 3 times, you tend to remember it. I mentioned this before, but worth reiterating. Compared to the RTL SDR and HackerF, the ARC's 888 is a considerably more advanced SDR, higher resolution sampling across the entire HF spectrum. Its ability to channelize demodulated signals with its own daemon. If you're just doing HF, the ARC's 888 is all you need. The HackerF and RTLSD behave like old school scanners, given a list of frequencies to dwell on for a short time before moving to the next one on the list. They are much narrower in their bandwidth, but they better perform at VHF and UHF. So if you miss it, you miss it. Sort of like an old school scanner. This build is focused on demonstrating AI use. In signals intelligence, presence and occupancy are the first steps in investigation. As stated before, to ensure clean demarcation between AI and interactive uses, a CLI switch is added and must be toggled between AI and signal analysis use before you use it in OpenWebRX+. When in interactive mode, again, the occupancy database is no longer being populated. We're going to look to address this in a future build. But again, the focus all along has been signal as intelligence in the first stages of it. What are we working on next? I originally started this project as a use case demonstration of sovereign AI because for me, amateur radio was going to be the only use case that was going to keep my attention span. Once I got past a proof of concept build, growing this into a signals intelligence platform had me realize I was going to have to take a step back from the technical and focus on process and workflow, and then make any technical alignments. The next build will follow this approach, starting with adopting existing SIGINT standards. Operations, how humans are organized and operate, interoperability, how systems format and share data, and architecture, how physical devices digitize and stream. Here's an example workflow that we try to walk through. Again, with the initial tasking of how we're going to collect the processing, the analysis, then the fusion of all that data. A lot of this is probably going to be built out as prompts and skills within OpenWebUI itself. Again, and actually ready reusable for using it in some of your own chat tools. K9Q supports more radios natively than just RX 888. Migrating HackRF makes AI use easier. The CLI switch remains should we want to use it interactively with OpenWebRX. This is the first step to expanding the architecture to include an edge layer that has all SDRs communicating to the uploaders through radio daemon, presented as multicast traffic. This setup works well with known frequencies that have potential for signals you want to monitor long-term, but currently has limited capability for discovery of signals on new frequencies and limited analysis capability for those new signals. But that is something we're looking to address in the next major build, where I actually would be able to control and configure these SDRs actually from within the multicast group itself. It's just a matter of adding security. But also in this, what I would do is actually just dedicate the RTL SDR with the OpenWebRX for doing signal analysis. So maybe you might have seen something of a presence on for occupancy, and maybe you want to go ahead and fire up an SDR just to go deeper analysis. So give you some initial capability on the platform. Again, this is just a first step of trying to have better synergy of your capability of doing deeper analysis on the platform as first initial steps. It's not ideal, but it gets us there. Then at this point, I'll have to revisit for MCP server, because from the MCP server, the way I would look at the radios as the SDR layer, the MCP server can make it that it abstracts selection of of SDRs. So in the queries, as it is today, the scripts take care of which SDR to go for. But we can even make it more abstract. We can actually go ahead and put some level of role-based authorization access to certain SDRs and certain channels. So this is going to be the next big level capability. And then these are some of the bullets within the MCP server that we can start addressing as well. The plumbing's there for these use cases. Visual comparison, low-hanging fruit. We already have the models there, just got to create any prompt. We also have something to compare against, which is the SIGINT wiki for comparing waterfalls. That's there. Triggering audio content, that's something we can actually add in. I would like to have it that one use case would be you're just monitoring multiple repeaters, and if it hears your call, you get a notification that gets sent up to the AI stack. There's already great tools out there with situational awareness and analysis in mind, with Kismet at the core. The intention is not to reinvent the wheel, but augment with AI capability to make the data more available for deeper analysis long-term, or notification capability. One example is situational awareness, tracking signals seen in your neighborhood, and notify anything suspicious in a human-readable context to the rest of your family via email, text, whatever. I hope you have found this journey helpful and inspirational for your own projects. QR codes direct you to my personal blog as well as my GitHub repo, where you will find how to build this yourself. You'll go to the repo and see Sovereign SIGINT. Everything's there, well documented, and should help you on your journey. Shout outs to all the people who have been inspirational and supportive in all these projects I've been working on. Take care. Thank you very much. Peace, and I hope you enjoy. And I hope this was educational and enjoyable for you. And good luck in your own projects.